good afternoon, and I think for some of you also good morning. My name is Jerzy Lech. I welcome everyone on our webinar. Webinar is about DSC sensors, a new technology behind this, and its application in food industry. I would like to explain how the development works, describe the advantages of different designs, and let you know something more about Chip-DSC thermal analysis in food industry. A few words about me. I'm sales manager in charge of Poland, Baltic states, Russian-spoken countries, and Gulf. I'm working for Linzai's Messgeräte since 2016. And of course, feel free to contact me via email or any convenient way. Linzai's Messgeräte company is a German manufacturer of instruments for thermal analysis, for determination of thermophysical properties. It is company with a long tradition. The company is family-owned company. It was founded in 1957 and headquarters is in Germany. We have also subsidiaries in US, in India, in China. However, production is in Germany, in Zelp City, where also our application lab workshop is. We sell worldwide, and we put very big pressure on being very innovative and introduce new technologies. The most cooperation is with German institutes, universities. We are also flexible due to knowledge and experience. We have capacity to design and manufacture many special devices adapted to customer requirements. The product range includes the complete line of thermal analyzers, differential scanning calorimeters, thermobalancers, simultaneous thermal analyzers, DSC DTA, and which is combination of DSC DTA and thermobalance. A lot of dilatometers, thermomechanical analyzers, instruments for a measurement of thermal conductivity and thermal diffusivity, the transport characterization of thermoelectrical materials and thin films, as well for the measurement of Hall constant. All this analyzer, or the most of these analyzers, can be coupled to gas analyzer, such as mass spectrometer or infrared spectrometer, GCMS as well. Therefore, pyrolysis or decomposition products also can be known. Our main topic today is DSC. We are talking about differential scanning calorimeters, which were invented maybe 70 years ago, and now we introduce a new technology. In our case, reference is fixed at the bottom. There is no second crucible. The instrument can be smaller. It has small layout, less thermal mass, and fast sensor reaction. Also, there is a bigger option available, DSC 100. Big version uses the same sensor, but more space, gives more options. Of course, the DSC 100 has also options of coupling with Raman, with camera, with UV light, many cooling options, auto sampler, or just customized coupling, because we are manufacturer also with customized systems. And system and instrument is affordable. This is budget friendly also, so it can be used also in quality control, where sometimes budgets are limited. So to compare, This is classic heat flux system measurement sample versus reference. And our system, how the sensor works in our case, Chip-DSC sensor, ceramic sensor. We use a little bit different technique. So as I mentioned, there is no second crucible, but bottom side of the sensor works as a reference. Something about classic measurement, what DSC can do, and where is the application? Mostly in industrial research, in teaching, and also in research, for example, in new materials. And what we could see is glass transition, crystallization, melting, oxidation, and decomposition. Everything what is connected with heat flow, the instrument is able to measure, is able to monitor in real time. Sometimes these phenomena are overlapping, and some effects can happen in the same temperature. So classic DSC has many applications also in food industry. Many investigations are possible due to different detectable transition, physical and chemical changes. So DSC is able to show phenomena with different height and energy. And also some investigations need very fast systems due to peak overlapping, especially when samples are not homogeneous. Good example is polymer sample. Some phenomena needs also high resolution because we have small TG. It means small glass transition point. We start production of different layout of different sensors. And in our case, we offer 3 kinds of main sensors: high sensitivity, high resolution, and standard universal sensors. All sensors are within our work and are within the electrical and mechanical limits. Removing or replacing the sensor is quite easy. This is what everyone can do. And also calibration is easy. And it's not time consuming. We have really quick result. So the application, because I think that this is the most important and most attractive. Main areas are determination of product quality, determination of moisture, food processing optimization, confirmation of country of origin, detection of falsified products, fast identification of oils, and finally, also the thermal behavior of some food additives. So due to ability of monitoring the heat flow, DSC is useful tool for quality control and research and development. Therefore, we have product for quality tests, also determination of moisture, confirmation of country of origin. What is important for regional products, protected products. So this is where we can use our Chip-DSC. Samples in food industry are complex mixtures. What is difficult for analysis? Mixtures of different ingredients which subject to be cooled or heated during manufacturing process. So DSC can help to optimize the industrial process and also verify the quality of final product. In practical application of DSC, it's not just only pure DSC, but also the instrument includes useful Raman spectroscopy, UV light, CCD camera with image analysis, and also Other option for DSC is high pressure operation. In every case, the upper temperature limit is 600 Celsius, which is sufficient for the most applications in food industry. Heating or cooling rate is adjusted by user in wide range from 0.01 Celsius per minute up to hundreds of Celsius. We go to application examples. First example is butter and margarine, so some fats. Task was investigation of water content and fats composition. Measurement was done with relatively low heating rate. In this case, it was 5 Kelvin per minute. We use for this instrument for Chip-DSC aluminum crucibles due to fact that this is optimal solution. We also can use copper, for example. So back to this application, the results are following. We see, as you can see, first peaks at Celsius or close to 0 Celsius degrees are result of water melting. Afterwards, the result of heating are endothermal peaks, came from melting of different fats. Different types of fats give different image of overlapping peaks between 80 and up to 140. So our mixture of fats were melting in this case, and the result is that in different regions, different temperature regions, we observe the melting of different ingredients in this mixture. Yeah, this is what I mentioned. Therefore, we can compare water content and different fats assay. And this method can be used for detection of product falsification and also aging, because we raise the temperature and some ingredients are starting to, maybe not to burn, but to oxidize. Another example is chocolate. So we investigate the melting behavior, the fat content and melting temperature. We tested 5 different chocolates. We again use aluminum crucibles. Sample mass was typical for DSC, about 20 milligram, and heating rate was 40 Kelvin per minute. Quite fast, but not the fastest we can do with the instrument. Measurements in air atmosphere, and we also used the cooling option to start from lower temperatures. And the result was different curves, different melting curves, and different type of chocolate yield different peaks. The curve shape reflects to the composition of the product. Double peaks are also visible, caused by different fats. So we have clear image that there are some differences between different kind of chocolates. Due to temperature range for this application, we recommend to use one of our cooling options, quench cooling or intra-cooler or liquid nitrogen cooling is also available. So we have more homogeneous peaks. We have the different samples show more or less split peaks. And melting behavior of chocolate could be also, as you can see on this example, analyzed by Chip-DSC. We can also analyze and have information about SFI, solid fat index, it can be also determined using Chip-DSC. Another example is skimmed milk powder, some conditions of these measurements we made. Our task was to investigate TG in milk powders, and sample mass was also typical, 15 milligram. Again, aluminum crucibles, heating rate 10 Kelvin per minute in air atmosphere, and for cooling the sample we used intracooler. We used these conditions for this measurement. Yes, we have in this case we have skimmed milk powder, which consists more than 50% of lactose, showing as you can see, it shows the glass transition about 81 Celsius. We use same type of crucible and sample heated in several times with different heating rates. In this case, 10 Kelvin per minute. And the result was depending on heating rate. The higher heating rate, the higher the glass transition temperature is. And if we use the higher heating rate, we have also the higher step on DSC TG signal. And we use two different sensors for this investigation. And yeah, this is outcome from our measurement. And you can see that the DSC, the instrument, is able to help us in analysis of skimmed milk powder. Another example, which is analysis of alpha lactose. We used also very similar conditions for DSC, but what was interesting is that we used Raman spectrometer coupled with DSC. So lactose analysis application is in combination with Raman spectroscopy. And as a result of its Raman spectra and several peaks corresponding to physical changes of our sample. So heating rate 10 Kelvin per minute, small mass about 10 milligrams, and we have different changes over temperature of lactose sample. DSC can be coupled with different analyzers to optimize the measurement quality. Another application is rice, investigation of gelatinization of starch from different samples. And we use 3 different rice types to be analyzed in aluminum crucibles, 12 milligram each sample mass, and heating rate 20 Kelvin per minute in air atmosphere. And also we started from sub-ambient temperatures. And what we see is that all gelatinization peaks are different, and it depends on the different rice type. And we were able to measure enthalpy of change, as you can see. And also we see different shape of different samples. Melting of rice starch is one of the application of DSC. Water assay, in this case, plays important role in this measurement. We are able to see and compare different types of rice due to different starch behavior. We are able to determine the place of origin as well, different kind of rice. Plant oil, another example, interesting, because in food industry, vegetable oils have play a very big role. So we use 7 types of oil. We tested to determine the difference between them. Aluminum crucibles, small sample, only 6 milligram each, heating rate 10 Kelvin per minute, and we also start the measurement in subambient temperature. So different oils, as expected, have different curve shape and melting points. We have here sunflower oil, olive oil, peanut oil, sesame oil, pumpkin seed oil, walnut oil, and corn oil. Peaks are within the region of melting of each mixture of fats, of oil fats. We use the instrument with cooling option. Application for end user is product falsification and potential quality issues. So we have clear baseline, and we see the peaks which came from melting process. If we raise the temperature, we see the endothermal peaks. Also, another application which I mentioned before is solid fat index. Is another area of application. SFI can be determined also for animal origin fats, not only for plant oils, but also for different animal origin fats. Specific application, which is mostly for polymers, but it has it can be used also in food industry, because there are some packagings made from foils, and this is about oxidative stability. Our system is able to measure oxidation onset temperature and oxidation induction time, which are important to know the oxidative stability of different materials, polymers, but also oils and food ingredients. All these details of measurements are described in international standard DIN and ISO 11357 chapter 6. This measurement can be done under ambient pressure or high pressure, it depends, and also it can be done in oxygen or in air. This stability testing is important because it gives some information about aging, resistance, parties of oil or polymer, and for example, plastic pipes or for water or other media or any food ingredients. So measurement can be easily done with air or pure oxygen as required, as it is needed. Yeah. So oxidative stability, OOT, oxidation onset temperature, gives information about, as I mentioned, oxidative behavior under dynamic conditions. According to this standard, heating rate is from 10 up to 20 Kelvin per minute. We use air or oxygen, and we see the signal how the heat flow is changing when we heat the samples. We use aluminum or copper crucibles, which has really huge impact on the measurement. Full details are included in the standard. However, the sample is heated, molten, and subject to influence of oxidative environment. So application example is sunflower oil. stability testing, we develop also special adapter which makes your signal smooth and stable. So you can compare the setup without OIT adapter and with OIT adapter, which gives us better signal. You see that this curve is going up due to oxidation. We have exothermal process, and the dynamics of this process depends on the heating rate. But everything is of course described in the standard. So how this adapter looks like, you can see on this picture. This adapter allows to deliver oxygen and or air close to the sample, and we have what is important for us, the signal noise is significantly reduced. Again, oxidative stability, sunflower oil, you can see how the data evaluation is done. It's quite easy. With good quality signal, we use two tangents, baseline and oxidation exothermal curve part. And yeah, it is clearly visible where we have intersection in this case. Beside oils and other food products, also polymers can be evaluated. So any packagings, LDPE oil, HDPE oils, foils also can be used. So in this case, for example, LDPE and HPDE can be separated using this method. This is more polymer example. However, packagings for food can be tested according to OOT ISO method. We can see also the data evaluation here, and this intersection shows us the point where this oxidation starts. Oxidative stability, OIT, very similar method, and it is also according to the same standard 11357, chapter 6. And a method is we measure time between switching the atmosphere to oxygen or air and visible oxidation process. So our sample is already molten, and oxygen reacts with our sample and gives us the exothermal peak. Exothermal, actually not the peak, but the curve just starting to be higher and higher due to heat which is released during the burning process. Yeah, we have here how the different kind of oils are reacting with oxygen or air, and you can see here that some oils are more resistant to heat and oxygen in these conditions, and some oils are less resistant. You can see here sunflower oil, walnut oil, pumpkin seed oil, and corn oil, and finally we have olive oil, which is the most resistant in these conditions. The application is, for example, food falsification, and also some issues in quality of products. We tested different oils here. You can see all the curves. Another topic is also, yeah, this is what we have done with oils. And as I mentioned, in this case, it can be simple test for quality control. If there is no oxidation, it can be expected as positive result. Atmosphere of this measurement is nitrogen switched to air, and temperature we lead this measurement up to 120 in copper crucibles. We can say there is no oxidation for olive oil, but we can see visible oxidation for sunflower oil in much lower rate. So other investigations is, for example, honey. We can find the fingerprint of origin for different kind of oil of honey, especially if there is some special honey from Tuscany or somewhere. It is just confirmation that this honey is really product from this area. Also, the second example is meat. Protein degradation, aggregation. It is also described in literature. For industrial processes, it is typical, or maybe not typical, but it is an example for mushroom technology. And what is important to know, the moisture assay for industrial process, and this is what also DSC can do. Milk, CP, we can determine CP with Chip-DSC, and there are more applications we can apply here. So that's why it is interesting to use DSC in food industry, because this method is relatively cheap, relatively fast, and it gives us also good result comparing to classic methods. Also, the instrument is not that complicated as some other instruments for quality control. So if you have any question, feel free to contact me. It was a pleasure to join here and show you some selected applications of our instrument, Chip-DSC. So if you have any questions, I'm looking forward to hearing from you, and we of course appreciate every type of input. Feel free to contact me if you have any questions. So the sources, of course, from which I used for this presentation, and yeah, feel free to ask me questions, especially by email, and just let me know. Thank you very much for your attendance.